The panel is titled Connected IoT Ecosystems for New Energy Challenges, which is somewhat obscure, but what I would like to talk about for the next 45 minutes is the topic of data and its value, what we think about that, how we're going to use it and collect it best, what are the best ways that we can actually turn it from something that is a bit scary into a commodity, and talk about what that means for energy. With me to discuss this, starting from the far left, is Michael Britt, who's the VP of the Energy Innovation Center at Southern Company. Next to him to my left is Todd Horsman, Senior Director of Strategy and Product Development at CPS Energy. On my right is Brent Hodges, IoT Planning and Product Strategy at Dell. And then on the end is Itai Dadon, who's the IoT product manager at Itron, formerly Silver Spring. So a nice mixture of people providing services and using those services. My name is Claire Curry. I run a team at Bloomberg New Energy Finance writing about emerging tech. So we are the energy research arm of Bloomberg, and my unit's based in New York, and we write about the future of the industrial Internet of Things and what it means for the energy industry. So hopefully we'll have a great conversation because there's lots of nice perspectives on the panel. First up, I wanted to define a little bit of what at least I think the IoT is, to give some context here. When we're talking about connected IoT for new energy transformation, the Internet of Things and digitalization in general, as we've heard about today already, is simply a way of making dumb things smart through computing power, connectivity, some sort of analytics platform, wherever that might be, and then some output. Generally, the output should be a level of control, not just a PDF printout with recommendations. And in theory, the whole thing should be relatively automated. It's not glorified consulting. It should really be a thing you can run as a business on your own, having installed it. The major drivers of the Internet of Things over the last few years, or at least the commercialization of this idea of IoT for industry, have been the high level of computing power we can now get on tinier devices for cheaper and cheaper prices. You can buy a sensor now for less than $1. It was $10 probably 5 years ago. Comms networks, the growth of things like LTE, potential of 5G, low power wide area networks, the idea of transporting large volumes of data much further and faster and cheaper than you could have done before. And analytics, things like machine learning, AI, just advanced image recognition, pattern recognition, things that we couldn't do before, brought on by chips, but also just developments in things like cloud. And so the aim of this panel, I hope, is to pick apart some of those technologies, discern what's most useful for the utility industry, and then talk a bit about how we actually get those things done. At the moment, the IoT has a lot of promise. In theory, we can improve efficiency, reduce fuel burn, automate processes, reduce labor costs, increase safety, secure our data more. But right now, there's very limited results. If you think about companies doing a lot of this, it's really on the pilot scale. That's partly because they want to be safe, and demos are a good idea, but partly because a lot of this is truly ad hoc projects done on certain parts of the business by certain startups or certain tech partners, and companies are yet to see how they can roll this out enterprise-wide and reap benefits from economies of scale. And I think that's something else we'd like to talk a bit about as well. So why is this important? Why are we here? I'm assuming, being at ETS, you believe digitalization is important for the future. I think it's really important for us to recognize that some of this we are being sold because companies need to sell stuff, and some of these technologies are exciting, and tech companies want more of your money, as do industrials, as do startups. Some of it is hype. But in my view, the reason why this is very, very important is we have to get a trifecta of clean, cheap, and reliable energy globally. And that means we're going to see huge amounts of more renewable energy on the grid. My firm does a forecast out to 2040. We're forecasting less than a third of the world's power will be provided by fossil fuels in 2040. And that means $6 trillion worth of investment will go into wind and solar. And if you've got that amount of volume of money in wind and solar, you're going to have a large amount of money in digital technologies, not just things like batteries and clever inverters, but things like software platforms and automation and control to make all of this work so that we can get to that triangle of clean, reliable, and cheap. So with that introduction, Todd, I'd love to come to you first and hear a bit about CPS's perspective on what the value of data is. When you look at your utility, what data points are really very important right now for utilities in the US?
So for us, I think the biggest thing is we're about through our AMI deployment, so we know what's going on at the end of our wires, right? And I go back to just fundamentally knowing what's going on at the end of our wires, so we can actually then end up controlling it, and that's the biggest piece of data for us. And then how do we end up actually mining that? We're then adding to that for our network, which is then air sensors. So we are muni. We're the largest muni in the country. So it's also what we do for our citizens, right? So how do we end up taking in data like air quality sensors, gas sensors? We sell gas as well. So how do we end up taking all of that data in and then doing something useful for our consumers, right? Because at the end of the day, they own us. And that's our biggest driver, is how do we give value and resilience to everyone that's in our network. So for us, it's really around taking all that data in, being able to analyze that data, and then be able to do useful things with it. And we're just starting, to be able to start tapping that big vault of data that we're getting in. When you think about meters, our meters used to get read every 2 months. And now we get them read every 15 minutes. Like, we absolutely know what's going on at the end of our wires. So how do we end up optimizing that? So, and that comes back down to basic spend and things like that, right? So do I upgrade a substation? Do I end up causing a whole bunch of costs to upgrade a substation versus optimizing a substation based on what's going on at the end of my wires?
So yeah, you're right. Huge amounts of more data that you can now collect. What's been the most surprising thing that you now see as being valuable data that you didn't have even 10 years ago?
So I will tell you, just something as basic as truck rolls. So I'll give an example to the group here. Is truck rolls for hot meter cans. If everybody doesn't know what a hot meter can is it's a meter that's running hot at 3 o'clock in the afternoon, right? And that's usually, it could be an over amperage situation, right? Well, so now we actually look at them and we say, okay, well, it's only hot between 3 and 5 in the afternoon, and that's because it's on the south side of the building with sun coming in on it. And, well, yeah, no kidding, it's hot. Right, in our service territory. And we're from San Antonio, by the way, for those that don't know, right? So it's kind of one of those things you can take that data and really take a look at it instead of rolling a truck. So we're down to like 3 out of 10 truck rolls now don't actually result in some sort of repair, where before 10 out of 10 truck rolls would go out there because of a hot meter can.
Okay, great, thanks. Michael, Southern, you run the Innovation Center there. What kind of data, I guess, is your company beginning to realize is essential, and how are they collecting it?
Yeah, so I agree. Certainly, meter data is critical. How your customer uses energy is critical. But all the way from generation through that consumption, we have data streams there in IoT that's monitoring how a generation unit is working, how our transmission grid is working, how our distribution grid is working, SCADA systems and so forth. But that's not new, right? I think where we what we're seeing is starting to take disparate sources of data and putting them together in ways we've never put them together before. So I think in terms of data, first realization before even getting close to monetization, just realizing what data you have is amazing. And we've got mountains of what I call gray data. And what I mean by gray data is data that is collected or available in a register on a device that is not collected or used today by the utility, but it could be or it's used for a single-threaded purpose over here, and it's not really accessible to the rest of the business. And so what I think is interesting is opening up sort of like a pull-down menu with a bunch of grayed-out items. There are a whole bunch of grayed-out items that are available to you, and I want to light those up. I want to figure out how do we start to create those combinations of information that start to give insights that were never possible before.
Yeah.
That's what I think starts to get really exciting for us when we take operational data and we take tree trimming and we don't see the performance improvement on the circuit that we expect. Maybe the guy didn't trim the tree. You know, so then and then you've got satellite opportunity and other things to quickly see, yep, you know, we paid for that, but it didn't happen. So there are a whole host of things, just insights that are available from data that today it might exist in different spots and different hard drives or different places around the utility. Bring it together in ways you never have before. I think that's what's exciting.
Yeah.
So I would 100%. I'm sorry to jump in, but I would 100% agree with that. It's so vegetation management as an example of that. It's amazing how much isn't shared across the utility for what that does in your distribution network and all those kinds of things, right? It's being able to get all that data across the entire organization so people can actually, customer service can do something intelligent with it. And our distribution grid can do something intelligent with it, right? It's really getting across.
And when you talk about the value of data, Google didn't pay $3.2 billion for Nest because their device was round, right?
Yeah, exactly.
They paid $3.2 billion because they wanted access to the data.
Yeah.
And when you think about it, it's only a fraction of the data that we have. And they would love to know what we know about that customer's usage and so forth. I think we're at cave painting stage of data in our industry and really need to advance.
Yeah, completely. And I think that's what's so interesting about the platform idea is how do you get all that data onto this just level playing field that everyone in your company can see the same thing. And Itai, I wanted to bring you in here and kind of on that subject, what are the most important technologies do you think that make up the Internet of Things as utility sees it?
I think that at the root, before talking about technologies, and we have to understand that when we're defining a solution, an IoT solution, we're trying to solve a business problem. And to solve that business problem, it might be driven by economics, solving operation and maintenance costs. It might be because of regulatory reasons that you have to do it, or for safety and security reasons. And then you have a choice to use the bare technology that is really restricted into solving that specific problem, or thinking a little bit more upfront, and we heard about what happened with AMI in the past decade, and actually build a solution that can scale and evolve into absorbing and providing all that data that today we don't know what to do with it. But I believe strongly that in the future, in the coming future, and this will happen faster and faster because of the technologies that I'll talk about in a second, we'll know much more what to do with that data and how to actually derive the value out of it. And one of the things when talking about technology is where to consume that data. And one of the most important trends that I'm seeing right now in the technologies that are relevant to us is the ability with the democratization of cost of hardware to compute. And this is what Dell does very well, as well as to us in Itron, at Itron, is really compute and deal and analyze that data at the edge. Why do that? First, because sometimes that's the only way to do it. Our networks, as you know, are relatively low bandwidth networks. They're not made for streaming Netflix over them. You're not going to watch House of Cards over there. It's really for AMI and IoT applications, which means that we have to keep them dedicated for those critical applications. So if we don't want to flood the network with video, if we want to, for example, count cars or to detect traffic or analyze air quality like we're doing in San Antonio, this is really about dealing with the data at as close to the sensor as possible. So that's one way of, one trend in technology. And the other is really the power of analytics and the introduction of very strong AI and machine learning tools that allow us to really take all that amount of data, whether it's in the edge or at the cloud, and really drive the essence out of it, which is the value. And we talked about cross-pollination of data. For example, one of the other industries that also are very close to our heart at Itron is the smart cities. I was amazed going to cities, and different departments don't talk to each other. You have the parking department, and then you have the traffic department, and the light department, and the water authority, etc., but they don't share data. But maybe the air quality has some kind of correlation with traffic. Maybe the parking has some kind of correlation with traffic. Maybe there's a lot of interest when you do city planning and urban planning to see how one impacts the other. And these are really the things, more than technology, the ability to get beyond the bureaucracy and share that data is going to be really important and interesting.
Yeah, thank you. Brent, from a technology company yourself, what do you think are the main building blocks that will help utilities with this?
Right. Well, I would go back to your first question, which was, kind of how you set up the panel to begin with, which is why do we do this? Why do we care? Because it has to do with, adding value for our customers and for society. And you quoted a statistic that, I find fascinating, about the amount of renewables that will be in place and as net new generation by 2040. What's powering that is the analytics and the capabilities that are now being brought to the table. So this idea of having compute and connected platforms at the edge where data is being generated is becoming central to the theme of how do you manage what's going on. If you're at a utility in the back office or in the operations part of the utility, I need to know everything I can about what's happening in my grid. So as CPS is talking about learning, we now know what's happening at the end of the wire. That's just the beginning of the journey. I think, as you heard, talking about adding air quality sensors as well. So starting to build this kind of holistic picture of what's going on around your business. And the reason for that is, again, to add value to CPS for their customers, as well as to value for the business itself. So what's interesting to us, what we've started to see from a Dell and a broader Dell Technologies perspective, you mentioned the following, prices of compute and connectivity and et cetera, all these trends, everybody knows about this, what's powering the Internet of Things. What we're starting to see, though, is, and Michael was kind of alluding to this a little bit, is that companies are starting to see that the value of the analytics, that they start by solving business problems. So they start looking at all this gray data. Why do I need to collect this in the first place? What should I be connecting? What am I not connecting now? And how do I locate compute and connectivity and storage and so forth at the appropriate point in my architecture? And so for us, we're seeing customers now coming to us wanting to do the value that companies like Dell have brought into kind of mainstream computing with people and connecting workers to their business over time, and the power of the cloud and on-prem and off-prem is now starting to happen in the OT world as well. So as a company, we've had a business over the last dozen years or so actually connecting and building technology into machines. Many times it doesn't even say Dell on the machine, but we've done things ranging from MRI imaging to helping to build substation equipment and other parts of the grid and things that would be more relevant to this industry. But what's happening is, and we just actually conducted some research study with Z-Prime and with some of our partners, including Intel, and getting ready to actually launch a white paper that talks about the value of these connected systems. So the ability to take these ideas and weave it together, solve a business problem, and really deliver the power of analytics where you need it in the environment, in the ecosystem, is a refreshing change from even just 2 years ago, where people would start a conversation about, well, what's your definition of IoT? Well, what's your definition of IoT? And you could have an hour-long conversation and you both just learn how to spell IoT because everyone has an opinion on it. And so I think we're seeing that now companies certainly have begun a digital journey, are much further along that path and are really using, the power of analytics. And really what's fueling this is the data, right? So it's all about these more connected sensors. You get more data, that's more fuel. I need engines like compute and connectivity that power the analytics, but it's all about driving value to the customer and to the business as well.
So we'll all agree this is a good thing. We should be doing it. why aren't we doing it? Why do you think utilities are struggling so much to actually install massive IoT platforms across their entire system? What are the barriers that you've seen at CPS or you're seeing some of your peers?
So I will say for CPS, I think we actually are moving forward. It's a slow pace, but if you take a look at what we're currently doing today, we are really looking to be the platform for our smart city. So our communication network that we already have in place, we have a variety of them, which includes our AMI network, but also includes a lot of fiber infrastructure and things like that. We really are looking to be the platform for it. We are out there deploying smart street lights, air sensors, so not, large scale air sensors that we have to do, but also small scale air sensors and things like that within our network along with the AMI. So, I think we're moving forward. It is, it's a managed progression, I guess is the best way I would put it. But we're moving forward. But for us, it's all around, what's the best benefit for our citizens, right? The people that we actually end up serve. So, do we go out and do active shooter sensors as example, right? We probably will, and they'll ride on our network. But it's really because we are city owned. It's how we move forward with that, and that's kind of the progression we take. I don't know, Michael. What do you think?
We're moving too slow, in my opinion. And I think the reality is that there are a lot of things that are difficult to move forward without some clarity from a regulator about investment for us. So an investor-owned utility has to go to a regulator and get some approval before you make it. We can do pilots, and we can test things out. But then when you're ready to go to scale, we're going to need to get a regulator to say, yes, that's good for all customers in the state. Because if you deploy it just in one location, how is this going to benefit all customers in the state? Some of the requirements that have to be met are pretty significant. 1. 2, we have a 100-year history of doing something one way, and suddenly telling somebody who's been doing it the same way since they came into that department 30 years ago because old Joe told them how to do it, that's pretty hard to do sometimes. So it's showing somebody that there is a better way and creating that value proposition for the people in your organization to have the demand pull saying, hey, I want that. I want that in my organization. When you suddenly can understand what happened on that circuit in much greater detail, that's stuff that I think these engineers get fired up about. But you have to paint the picture, and you have to give it to them first in pilots. And so it's just an iterative step, iterative process, unfortunately. And I think also skills. Frankly, we are competing on a global scale for data scientists. Are our utility pay scales going to be able to afford the kind of data scientists we need and then retain them over a long period of time? Because by the time they have developed these skills and capabilities, they're extremely marketable. Can they really exist within our operation, or do we really want to outsource that function and that capability for extreme data analytics? I think we have to figure that out. I don't know yet.
Yeah.
So I will say that the one thing I will echo there, especially for us, is the equity piece of it. Right. So what we go out and do within our community has to be equitable across all of our communities. So we've got different demographics within our service territory, and that does create
and they will have different needs in different areas.
Absolutely, and it's a huge challenge, right? It's a huge challenge to make our different areas of town equitable.
Yeah.
I see two other things to kind of complement. The first one is the validation of the business case, which is critical. What I saw in our experience at Itron with, for example, the streetlights. In the beginning, it was very tough to convince that by connecting controllers to streetlights beyond just simple photocells, there is value. There's a lot of things they can gain from it. Today, we don't even have to talk about it. People are convinced and they understand, and the pace of growth is maybe 10x what it was when we had to explain why it's useful. That's number one. And the same goes application by application. The second is that the ecosystem is boiling. There is so many startups and companies doing stuff. It's hard to separate the noise from the things that actually work. It's really hard. And in industrial IoT, when we're talking about putting device for 20 years in the field, I think there is a process that is normal to take it a little bit slower than the pace we're buying new iPhones, to validate the technology is really working end-to-end, not just connecting the sensors and showing on the PC next to it a nice graph. It really has to be the end-to-end solution, and the difference between a demo and a well-tested and validated end-to-end solution is years light.
Yeah, definitely. I mean, I'd add another barrier in there, which is the nasty topic of cybersecurity. I think, Brent, we were talking earlier about the cloud. A big part of analytics that's truly valuable can be done in the cloud for the OT and IT data. So I'm sure companies like CPS are using cloud for enterprise data or kind of AMI data maybe, but it's very hard to persuade utilities to use the cloud for kind of operational transformer data. And if you can't use the cloud for a lot of your analytics, you're going to struggle to have that holistic platform. Potentially, that's what cloud suppliers would say. I mean, we talked about this a bit before and the drive toward the edge. Is that something that's going to help overcome that barrier?
Well, again, I think it's a useful tool. I mean, and again, just as people are discussing the cloud today, as it becomes more mainstream, the world is talking about fog, which is really kind of edge computing and moving things back. And I don't think there is a one-size-fits-all. It depends on your use cases, depends on the business models at hand as well. But ultimately, I think the idea that we're seeing embraced is to think more holistically about your infrastructure. So think about your OT and IT convergence, if you want to call that IoT, but think of it holistically from an infrastructure perspective, things that you're going to need to deploy for a decade or more, which is what utilities are expecting. That's not your traditional iPhone model and so forth. And it's just this idea that if I need to do computing at the edge and do analytics and I can solve problems and run my software there, so be it. I might not need to take as much data back to the cloud. Clearly, there's a lot of data, though, that makes a lot of sense when you can take it, and by saying cloud, you could be on-prem or off-prem with big data servers and analytics packages to look at long-term trend, to look at a blend of data from multiple sources, and being able to identify other anomalies that you might not be able to capture locally. That's some of the holistic powers of big data, as people would call it. And so I think depending on your business, you'll make choices on, this system or this application I might want to run here. This application I might want to run a bit more holistically here. This other application I might want to run in the cloud because I'm benefiting from lots of other inputs. And so what we see is not one size fits all. And so starting with that end in mind, starting with what business problems you're trying to solve really can help lead you down the path. But thinking about it more holistically, the trend in the past had been a little bit more siloed, where you'd pick an application which came with a sensor and a gateway and an app, and then you'd somehow hope to do the data integration later in the back office. I think people have proven the fragility of that model, and the pain and suffering. And so I think as we're going forward applying IoT or this kind of fog computing, if you will, you're seeing a little bit more architecture coming into discussion earlier, with business outcomes in mind that allow you to better plan. And I was going to add, the other I think you're kind of referring to is really the technology maturity. I think even in the last 5 years, or I know the opening session, if you guys were there today, the presenter Christine was talking about 20 years ago, how she had one PC in her family, and the cool kids just subscribed to AOL by the minute, and she made mixtapes because that's what she had access to. It's easy to forget how far we've come in just 20 years. And I think in a utility context, you're thinking about decades, right? You're trying to do IRPs over 20, 30 years, and you're looking out at these new statistics, like you mentioned, and how to plan for that future. You've got to have more than just an app for that.
Mm-hmm. So the one thing I'll add to that, which I thought was fantastic, is I'll take just something completely basic to us. So physical security. Mm-hmm. So we've got cameras now that go out in our substations, and they do the complete processing on their own, right? And then they phone home.
That's right.
When they see something that
Yeah.
is outside the parameters for it.
We've
right?
seen a big, actually, kind of business develop around that, and you're absolutely right. And it builds on things like machine learning and some of the advanced algorithms that you can run. And it's a great example where you can learn things at the edge. I can run a certain set of algorithms, but if I have a lot of cameras across my whole territory, I want to be bringing back data about anomalies. And over time, I can learn from a big data perspective other things to look for, and I can update the algorithms locally to then look for the new anomalies, right? And that's the whole concept of machine learning and big data, and then applying it back to the edge.
That's the thing. It's not streaming it back, and it's not a human sitting there looking at
Exactly.
it to try and understand it.
Yeah.
It's I've got events happening.
Yeah.
It comes back to the mothership,
Yeah.
if you will, when you see it, and you can start saying, well, was this a tree break
Right.
on a line or something like that, versus was it really an active shooter at a substation or something like that, right?
And the beauty is really to think how to make that camera become smarter and smarter over time, so that it detects even more stuff and can really learn and understand how to be more useful to you over time.
Yeah.
Exactly.
Yeah, that is really interesting, and I'm excited to listen to all these technologies you're all using. I wonder, Michael, when you think about innovation at your company, who are the best partners to partner with a large IOU or regulated company? Do you think it's still the industrials, so someone like Schneider or ABB is still the best partner to install brand new digital technologies? Or are you looking more towards startups because they're maybe cheaper, maybe have the best, most exciting scientists? Or is it more big tech because they know technology well?
We work with all three. I mean, I would say that each has their own capability that they're going to bring, and the utility is a piece of this, right? We have infrastructure. We have vertical infrastructure poles that are every 90 feet that give you vantage points for video, for lighting, for sensing, all kinds of things like that. We have horizontal infrastructure in terms of conduit that run fiber, and also vaults that could also provide platforms for sensing. But working with the big industrials, they're able to deliver things that are at-scale solutions that are very hard for a startup to deliver. But startups can sometimes have a unique solution capability that if you can plug into it and resource it, so through EIP, Energy Impact Partners, our venture capital arm that we and other utilities share, we've invested in a number of these companies that a few of them are actually plugging into our core processes. And so we're working with all of those types of companies along with the big tech companies. We work with, we work with Nest, we work with Tesla, we work with Amazon, all of them on solution sets around IoT. We're building a neighborhood of the future, we built a neighborhood of the future in Birmingham, Alabama, where we, again, trying to answer that question, what's energy use going to look like in 10, 20 years? Because we have to make decisions 20, 30 years out. And who the heck knows, right? Who knows? This is our best cut at it, where we've taken the ultimate thermal envelope, the ultimate 20 SEER heat pumps, and everything you've ever dreamed of, all the IoT platform fully integrated before the customer moves in. So they don't have to buy it and try and figure out how all the different Tetris pieces fit, right? We've done it all for them, fully integrated. So they walk in the door with an Alexa and they can say, I'm going to bed, and it locks the doors and shades come down, lights dim, fans turn on, things like that, right? So we're very interested to understand how will customers engage with this technology around energy, their visibility into it. It's a very opaque product if you think about our product. We send a bill to somebody a month after they used it. They have no correlation between even a phone bill, the old school phone bill you got, you could at least say, who the heck called New York, right? Madison, right? That doesn't, there's nothing like that on a power bill. You just have a power bill of $327 one day that you never knew, there's no correlation. Oh, it's hot, it's cold, whatever. So I think this is important to give visibility into how people use energy and help them figure out how will people care when there's so much passive energy management in the home. The ultimate thermal envelopes, right? Ultimate SEER units. Does anybody care anymore when their bill is a third of the most efficient homes built today? That's kind of what we built in Birmingham. And we're going to see, so we have a 2-year longitudinal study that we're doing with a number of those companies to try and understand how customers are going to use energy. They've granted us access to their data for about $50,000 of upgrades per home. So it's pretty significant. And then we're doing the same thing in Atlanta, but a different model. In Birmingham, it's got community solar and battery and microgrid. This neighborhood is a microgrid in in townhomes with rooftop solar, battery, integrated batteries, but the rest of it is identical. So it's sort of a different form factor. But we're going to learn how customers interact with technology. Is it really all about set, forget, and it's about comfort, convenience, control, which is what we believe? Or will customers engage around how they use energy? Will they actually care and dig into trying to drive a $30 bill to a $20 bill?
Interesting.
I don't think so. But you never know.
Yeah. So we've heard about what we think the future of the home looks like. Itai, do you want to wrap us off? Because I think we are probably about time with what does the future of the smart city look like? When Itron does the same thing for cities that Michael was talking about for homes, what can the IoT truly do for a city?
Yeah, maybe a good way to answer it is kind of touch on what you asked before. I think it's one thing that we realized is that smart city and both for IoT for utilities and for smart cities is such a vast domain, so many applications. We can put our fingers on some today and many more are coming in the years to follow. And there is a common understanding, and we got to digest the fact that we just cannot do it all. So we have to combine the ability to use our knowledge of how to provide complete end-to-end solutions that are secured, reliable, and scalable to our customers by leveraging the agility of our ecosystem and reaching out to our ecosystem. We talked about these air quality sensors. They're coming from a startup in New Zealand. Okay, we're talking about parking cameras, coming from Brussels. We have a solution for radiation detecting coming from Minnesota. And these are the best in class of each one of these applications around the world. And we cannot either or want to compete with them, but we have to enable them as part of the complete solution that makes sense for the city, that the city can grasp and understand it. I'll give an example of a digital sign. If we provide a digital sign that is connected to our network to a city, oh great, looks good. What do I do with it now? How do I make money out of it? How do I inform my citizens with it? How do I get the content for it? No, it has to be a much more complete solution with the ad marketing agencies that provide the content, that explains to them how to use it. This is the future of smart cities, really providing a cohesive package for the cities that will make sense for them and for the citizens.
Great. Any final comments? Todd, Brent? No? Let's wrap there then. Thank you so much. This has been really great. So we have 2 minutes for questions. Now is your time to... Okay, great. Yes. Sorry, you have to shout, I think, because it'll be too... Well, there's a microphone there if you want to go, or just... We're close. You can talk. Yeah.
So I'm MK. The Chief Revenue Officer for Safeguard. We make electricity safe through our IoT device. I actually work in the same building as Michael does.
Excellent.
In Atlanta.
Building, all right.
Yeah, and I know Itai because I used to work at Itron Idea Labs. But my question is actually more fundamental for IoT. So you guys talk about IoT, and the most fundamental component of IoT is communications. And over years, in the last 2 decades, we've seen AMR, AMI, smart grid, all of this come, but still we're lacking in terms of where we're going in terms of communication for the edges. So major parts of the world are still not covered by mesh or PLC or even cellular for that matter. Where do you see that communication, that sort of innovation progressing, into the communication world, so that really, not only the people in the urban or suburban areas can use the IoTs and take advantage of that, but also people, on the edge, on the developing sides of the world?
Yeah, I mean, so I can take a stab at that. I mean, so in my product portfolio at Edge IoT, we look at these different communication technologies. I'm sure you're aware there's a whole new class actually of low power WAN technologies, ranging from the traditional kind of licensed model around narrowband IoT and Cat-M type connectivity to the unlicensed spectrum, where you have really kind of LoRa and LoRaWAN as kind of emerging as being part of that fabric. And so we think of it that way. We think of it as there's connectivity for, I think of horses for courses, right? I mean, it depends on what your applications are, what your use cases are. A lot of the value of those newer technologies is it's much lower cost. It's a lower cost to implement. It's a lower cost of the data plan itself, or it's even free if it's in the unlicensed spectrum. The trade-off is that the bandwidth is even smaller. I know you were referring to some AMI networks being dedicated. It's even an order of magnitude less than that, but you get range, you get cost, you can get coverage, and so we've seen we're working with a large telco partner, for example, in India, who's implementing a nationwide network of such low power wide area networking technology. I think from our customers' perspective, I mean, what we're looking to do is provide this connected compute platform that enables multiple technologies to be chosen. It could be upgraded or changed over time. I think there's, the promise of 5G is not in one radio to rule them all. The promise of 5G is it's multiple technologies, multiple spectrum options, trying to be blended together into a more dispersed and wider coverage model. And it's going to have some fascinating possibilities, both at the high end, which is what the sexy video streaming stuff looks like, versus the really low power, far-reaching, millions and billions of devices being able to be connected. So it's an exciting time to be around this industry, and there's going to be multiple solutions for different types of applications.
Thanks. Any other questions? Yeah.
So I'm Stephen Johnson. I work with Chai One. We get sent by energy companies to observe users and their problems and design and rapidly prototype and scale solutions. So big data is being collected in real time, but what you can do with it takes a little bit longer. So when you think about the business users of big data who are ultimately making decisions at some point that are used to Amazon at home, right? That today, if they want to make some sort of decision or get a Power BI dashboard or something out of this data that we're collecting, it's very difficult to do that. It may take a lot of time to get that back. What sort of experience are you creating for people to self-source some data on the business side to start making decisions faster?
So we have a product called Energy Direct, which is a data platform for large to small business customers. Our largest customers have usually their own systems, and they just read in the data and through an API and manage it themselves. But Energy Direct is one tool that we use to help them source access to data, make it meaningful. And we're in the middle of trying to redesign that to align our new offerings, because we have a whole host of new things we're now delivering to that customer base through our Energy Direct solution.
And I'll just add to that. So we have a very similar thing, especially for our CNI loads, so our big loads. But internally, we're also building out a platform that internally our CSRs, the people that answer the phone on every day, that can go in and actually help mine all the data that we have, as well as our distribution planning teams and things like that can take all this data that we're now getting. It's just a massive amount of data. Is put a platform out there that they can actually be able to mine it and actually understand, okay, that transformer's overloaded, or whatever the case might be.
Great. One more question. Oh no, we're being told that's a wrap.